Good morning, class, and welcome to Miss B's online class. Since I am teaching two different courses, you get the pleasure of experiencing my online class. So I hope you enjoy it and that you'll learn something today. All right, so I just want to preface this, and I'm going to set down my clipboard and just talk to you about how we have been comparing functions. We have talked about how functions can be represented using words, graphs, tables, or equations, and that when we learn the relationship among these representations, it can help us compare the properties of the two functions represented in the two different ways. So for example, if I had a graph and I had a function, well, I could still make sense and compare the both even though they're not both graphs or they're not both functions. So I'm going to teach you a couple of ways of comparing these different types of representation of functions when they are not the same. So let's take a look at my first example. Okay, my first example shows the following. It says which function has a greater rate of change. Now, we know the rate of change is you should know this, that's right, it is the slope. So when we're looking at these, there is one I can easily figure out the slope to, and that's this one right here. Why? Because we know y-intercept form. Y-intercept form is y equals mx plus b. And when I look at this here, this equation automatically tells me my slope and my y-intercept. So if I look at this, I know that 4 is my slope, which is our rate of change. So I automatically know that the rate of change for this one is equal to 4. All right, but what about this table over on the left here? How am I supposed to figure this out? Well, luckily we have 2 points. And if we have 2 points, we can find the slope. So we can really select any 2 points that we want to. It doesn't matter. I know a lot of you guys tend to just pick the first 2. That's fine. What I'm going to do today is I am going to select the first and the second points listed in the table. So that means that I am going to select this one here and this one here. So I can just go ahead and find my slope. Easy peasy, lemon squeezy, right? So let me just shift this so that I can write and you can see. I'm going to say m equals, well, remember, I need to make sure that I'm grabbing my y's first because they go on top. So I'm going to start with 14 and then minus 5, my second y, over 4, because I started with 14 comma 4. I need to start with this x, minus 1. All right, when I subtract this, I'm left with a fraction of 9/3, which I automatically know is 3. Again, since 3 represents my slope, all right, which we know is the rate of change, I know that the rate of change for the table here is 3. So when I compare them, this one's rate of change, the table, is 3, and the rate of change we found from the equation is 4. I know that 4 is greater than 3. So therefore, this function here, the one written in y-intercept form, has a greater rate of change than 3. Pretty easy, right? All right, well, now it's your turn to try. So what I want you to do is I want you to look at this problem. I'm going to show you now. And I want you to pause the video then and take a look at it. It says, which function has the greater rate of change? Explain to a partner your answer. So just like we did before, we're going to look at a table and an existing function, and we are going to decide which one has the greater rate of change. Remember, the greater rate of change is the slope. So go ahead now and pause the video. Okay, now that you've solved this, you should have come up with the following answers. First of all, let's start with the easy one. Well, since this is in y equals mx plus b, we automatically know that 2 is in the position of m, so therefore our slope and our rate of change is 2. Now let's look at the table. The table, all right, once again, I use the first and second points, it doesn't matter though which one you use, has a slope of our y values minus our x values. So I took 25 minus 5, and then I did 6, my x values, minus 1. And I got 20 over 5, which we know is 4. So when I compare these two, where this slope here is 4, and this slope here is 2, which is our rate of change, which one is bigger? Correct. The table now has the greater rate of change. All right, so we don't always represent our functions in graphs and functions. We can also represent them in, or we can also compare them, by linear function, or by the initial values. We can compare linear functions by the initial values. So let's take a look here at this one. All right, so this is going to really show me who your favorite teacher is. We have Miss Budenz's soccer camp and Dr. Kleinert's soccer camp. And when we're looking at this, we're given pieces of information. However, the problem is we need to find a relationship between these two which is comparable. Because when I'm looking at this, the first one for my camp, which automatically I think is the best, it says that it's $18 per day. Well, right there, we have an initial value. But Dr. Kleinert's isn't set up the same way. So, okay, we've got Miss B's here. It's $18 per day. Oh, I'm sorry, that is not our initial value. That is our rate of change. But then we have a registration fee of $89. So I have to pay $89 no matter what, and then an additional $18 per the number of days I go. So if it's 1 day, it's going to be 89 plus 18. If it's 2 days, well, 18 times 2 is 36 plus 89. That would be the cost of the camp. Now, Dr. Kleinert already has 2 days cost $121 and 7 days cost, and I forgot to write it down, $236. So let me add that. All right, is $236. So when I'm looking at this, I can say, well, let's compare the initial values. So how am I going to do this? Well, first of all, Miss B, of course, has it simple. $89 registration fee. It's automatically going to be that. So I can go ahead right away and I can say for Miss B that the initial value is $89. All right. But Dr. Kleinert's initial value, we don't know. But we can figure it out pretty easily. All right, so what are we going to do? This is our question. What is the initial value? Well, first of all, we need to put it into y equals mx plus, let me adjust this, b form. All right, so the first thing that we need to do is we need to figure out the slope. And we can figure out the slope because how Dr. Kleinert's information is set up actually easily allows for us to make up 2 points to find the slope. So I can take, I'm doing this on the side here. All right, I can do, I'm sorry guys, I'm still learning how to do this technology stuff. I can have the point 2, 121 coming from the table that 2 days cost $121, and then the other coordinate point, which is 7, 236. All right. Now again, I'm going to encourage you, because this is where I see mistakes, that this is your X and this is your Y, and this is your X and this is your Y. Make it easy for yourself. Label them, okay? There's no shame in labeling, all right? There's people who have bigger problems. They're the ones who have the label makers. Anyways, so what I want you to do is then I want you to find slope using the slope formula. y2 minus y1 over x2 minus x1. So let's go ahead and set that up. All right, and we have m equals, well, I'm going to start with the biggest y because Miss B doesn't like working with negative numbers, 236 minus 121 over, now my x value, 7 minus 2. That gives me 115 over 5, which easily simplifies to 23. So we know now that there is a rate of change of $23. So I have part of my y equals mx plus b equation, but I'm still missing my plus b. So what am I to do? Well, the handy thing is, again, I have 2 points up top here, so I can choose one of them to plug into my x and y. So I'm going to go ahead and do the 2 and the 121 because they're the smaller numbers, and I am going to do y is 121 equals 23 times my x value of 2 plus b. All right. We have 121 here. 23 times 2 is 46 plus b. Now remember, I need to do the inverse operation. Since this is a positive 46, I'm going to subtract 46 or minus 46. That's why you heard the little and we'll solve for b, which is $75. So if we come back up to our original question, which one has the greater initial value? Well, we find out now that Dr. Kleinert's is no longer a mystery, but rather it is $75. So we can compare them using the initial values. Miss B has an initial value of $89, while Dr. Kleinert's initial value is $75. So my baseball camp has a greater initial cost. Now, we can't really say mine is better as much as I want to, or it's worse because the initial value is more. We would have to do further analysis of the functions to decide that, because my per day cost is actually cheaper than Dr. Kleinert's. But we won't get into it today. I just want to show you that you can compare the initial values, or our b in the yx plus b form, to compare two functions. All right, so now it's your turn to do an example. We're going to take a look at this. All right, so first of all, we've got Miss Reynolds bike rental. It's $17 per hour plus $29 rental fee. So what is her rate of change? Good, it's $17. And what is her initial cost? Well, it's the initial fee of $29 to rent the bike. Now, Mrs. Strauss, on the other hand, again, does not have the information relayed the same way as Miss Reynolds. She says simply it's $48 per 1 hour, and it's $108 for 4 hours. So, let's take a look at my question I wrote to you. My question was, which company, Miss Strauss or Miss Reynolds, has the greater initial cost? So what I want you to do is I want you to look at these two teachers' information, pause the video, and decide for me which one has the greater initial cost. So now go ahead and pause the video. Okay, so you should have solved this problem now. Now, once again, it was really easy, just like mine, something about that, to find the initial cost. Miss Reynolds, if we look, it's given to us in the information. Her initial cost is $29. Now, Mrs. Strauss's initial cost, we have to do a little work. And we have to find the slope. Now, one thing I want to point out to you is usually when we represent, information like cost in hours, which is time, time is usually going to be our x-axis, and cost is like usually going to be our y-axis, because we want to see the rate of change as time increases. How is the cost? That's the most appropriate way to look at it. So we needed to keep that in mind for when we went ahead and we did our slope. So again, Mrs. Strauss's information, easily the $48 for 1 hour and then $108 for 4 hours can easily be translated into x and y coordinates, and then we can solve for the slope. So I'm going to take the 108 minus 48, and I get 60, and then the 4 minus the 1, and that's 3. 60 over 3 is $20, which we can plug in then for our m. All right, so what am I going to do next? Well, I have to find out what is b, because we want to find the initial cost, and remember, initial cost correlates with b. So what am I going to do? I'm going to plug in using this xy coordinate into my y equals mx plus b equation. And first I'm going to put 48 in for y, okay, and then I'm going to put in 1 for my x. That allows me to have one variable to solve for. So we end up with 48 equals 20b. Again, 20 is positive, so we do the inverse operation. So I subtract 20, I subtract 20, and I get 28 equals B. So the initial cost for Ms. Strauss is $28. Remember, Ms. Reynolds was $29. So once again, we can't decide whose bike rental is cheaper, but we can compare them by looking at the initial cost. All right, now if you remember earlier in the lesson, Miss B had you look at step graphs. Now, there was an important reason why I had you look at step graphs, and that's because they show us these. Now, unlike what I showed you, these are nonlinear functions. Remember, from chapter 3, when we looked at it, that nonlinear functions are ones that don't go into a straight line. So for this one, I'm going to take a look at the book example, and if you would like to, you can follow along, and I'm just going to talk about this. So if we have this one here, all right, it's comparing two nonlinear functions. We have Jack and Manny, and they each have a savings account. So they're putting money into account they're putting money into an account, and their goal is to save. However, one of them is better than the other. So let's first look at the graph on the left, which represents Jack's savings account. Now this is a step graph, and remember, we read it by looking at the dark filled in circle. So at 0 days, he had an initial amount of $100. 6, he must have gotten some extra money, and he had now $200. Remember, we look at the filled in circle, not the open circle. He took out a little money come day 12 because it drops down to $150. And then day, I would say 16, it goes back up to $250. So he deposits another $100, and it goes on. All right. Manny, however, let's look at his information, starts off with an initial deposit of $500. If I were looking at this on a graph, the y-intercept would be 0, 500. He's starting off with a lot of money. However, he withdrew $20 each even number day for 30 days. That means, if you look at my calendar, ooh, it's kind of big. And I'm going to zoom out, don't you worry, that every day Miss B has circled on this calendar is an even day. He's withdrawing $20. Well, if there's 30 days, the evens make up half the days, so that's $15. Or that's 15 days. So if we're looking at Miss B's calculator then, all right, so we're going to do 15 days times 20, that gives us $300 he's going to withdraw over the entire month. So with his initial $500 minus the total amount of $300 he withdraws over the whole month, there is only $200 left. So let's go back to the book. Give me a second to readjust. Let's look back at the book. So when we compare these two nonlinear functions, we find out the following. As we can see, based on this here, Jack's account increases and decreases. Whereas when we look at Mr. Manny's, his just decreases. All right, they're not continuous. Both are not continuous. We see this because it jumps around because he keeps adding, then takes some, then he only adds a little bit as opposed to a consistent amount. So Jack's is not continuous. Same with Manny's. We know his is not continuous because he's only doing every even numbered day for 30 days. So it's not continuous. It would not be in a straight line. So we can compare them by looking at the information we know. If we look at Jack's, his minimal amount in the account, according to the graph, says $100. We don't see it drop below this $100 line. His maximum, though, is on day 26, where we see it is at $400. So his maximum, 400, his minimum is 100. Now, Manny, he started with a maximum of 500, but has a bit of a spending problem and spent $300, or he took out $300, which left him with a minimum amount of 200. So, which one is better? Well, that depends on our question. If I say, who's better at saving money? I would say Jack. He rarely takes out money. You only see him do it once. Manny takes it out all the time. So he's one of those people, as soon as he makes money, he spends it. Jack sees the value in saving. However, if I want to just know who has the potential to have the most, I'd say Manny, because his maximum is $500. So there's a lot we can do with comparing fractions, and we just have to make sure we are finding things that compares the fractions on even playing fields, even if they're represented in different ways. We can look from a table to a function written in slope-intercept form. We can look at the initial values to compare, and then we can look at a table and then information we're given, like in this last one, to compare them. All right, look back at Google Classroom for your next assignment.